use a bit everything we learned to create this animation here. I will be starting a completely new file, so you can follow along if you want. To change this to cycles, experimental, GPU. I will change my subdivisions to 1. I will add a subdivision surface modifier with adaptive subdivision and simple. I will go to my shading tab. I will use the default material here. I will change on my material settings my displacement to displacement only. The first thing we are going to do is add a texture coordinate, create my center coordinates. Then, if you remember, vector math, our line of conformations, and also we subtract to avoid adding these colors again to something that already has a position. I will switch to render view. I will plug my displacement. My first step will be using normalize to change it to a sphere. Then I want to separate this into 2 spheres. One I will be using for the shell and the other one for the content inside the egg. So first I will use my separate on X. I have -1 and 1 here. So I will use math. I will use absolute. So we have 1, 0, 1 now. And I will use another vector math. And I will multiply what I have by this mask. We replace this. We get our 2 spheres. So this will be basically our starting point. You can even name this, so you later, when you have a lot of nodes, you will know what they are doing. Cube sphere. And this will be sphere to 2 spheres. So now I will create some things that I will be using along the entire process. So the first thing we need is something to separate these 2 spheres, mask that will separate 2 spheres. So we will use separate. We will use our X. As you can see, we have -1 to 1. So we can use a math node and greater than 0. This will be our right sphere mask. And we can create another one with Alt-P. You leave the frame. And this one will be less than. Ctrl J. Left here mask. I also want a mask to create the transparency between them to hide the part that is joined. So another one will be, and in this case, I will use compare. And I will compare 0 to my, like another value here. My alpha mask size or width. I want something small for now, 0.01, and this will be my tolerance or epsilon. So let me remove extras and 3D cursor so we can see better here. And also my origin. Okay. That's what we will hide or make transparent. So this is our alpha mask. And we can already use this, since this will be white on our mask alpha here. White, it's basically the opposite that we need, because we need alpha 0 on this part. So I will invert this mask like this on the color, and our factor will convert it to the opposite. And this will be our alpha. Now I want center coordinate for each of my spheres. At this point, my coordinate is centered here, so if I do transformations to this, I will have strange behavior because it will rotate around this or scale with this as the center. So I want to use mix RGB. I will plug this to both inputs. I will use my mask as a factor. So now I have, even if we have the same content, but this will be, the bottom part will be my right sphere. I want to use vector math. And for the right sphere, I will subtract on x 0.5 and add 0.5. That will shift our coordinate. And since we are using a mask, now this will be shown only on the right side and this on the left side. So we end up with center coordinates on both spheres. Okay, at this point, we could basically create two timelines, one for each sphere, and treat them as independent displacements or vector displacements, because each one has its own coordinate, and you can use at the end of each timeline a mask that will make affect only that sphere, and you can join them at the end. Since I don't want you to incorporate new things at this point, because we already went through a lot of information, so I will keep it as we did before on one line, but I will probably add a few videos after the release of the course with tips and more techniques that you can incorporate later when you are a bit more comfortable with vector displacement. Next step, we want to take our left sphere and transform it into an egg shape. So the first thing I have to keep in mind is that any transformation I do now, I have to multiply by the mask of the left sphere. so I avoid modifying this one. I will just add it to math, multiply, and this is my left sphere here. This will act like a filter. Now we could just use this as it is, but for people that is starting, it may be confusing to also have the colors of the right sphere, because anyway we are going to multiply it at the end by our mask, so it won't matter, but it may be confusing, so I will remove it at the start also. So I will vector math, take this and multiply it or scale it by our mask, so you don't see these values there. But you can avoid using that if you want. So first thing, I want to make it larger, because it needs to be larger than the content. I can use the same values that we have here to duplicate the size. And I can then add this to our line. As you can see, we already have the size. Now let's take care of the shape. Okay, so now I want to give it a bit X shape. I will use my X, and I want to leave this part as it is and take this one and stretch it a bit, so we get something like that. So I will use a map range to take, instead of -1 to 1, I will take from 0 to 1, so from here to here. That will be 0 to 1 now, so it's the same but without the negative values. And I will use vector math to add to what we have and combine. This will let me plug independently, because I cannot plug this to a single axis there. So with the combine now, we can plug this into the X, and we will be adding only to X and only to this half of the sphere, so we get some sort of X shape. You can always use your principal shader to see a bit how things are going. I will change at this point my light for a sun lamp for now. Now I want to create the mask. This separates the shell in two. Separate again. So I could use the same text we have here, but I will do it separately because I want to also give it the shape you saw, like the cracking. And I will need a different one. I will take my coordinate and use mix RGB. Plug it on top. And I will use a noise texture here. Plug the same in this vector and the color here. Change this to linear light. And now with the factor, we can add noise to this coordinate. As you can see, the size will also determine the size of this. So we will use this to separate. We will use now a compare again, math. compare. And we will compare 0 to maybe 0.01. Now we can use our noise. And you can play a bit with the settings, the roughness, and the size maybe. I think that's okay for now. And now we can add this to our original alpha mask. We have the separation between the two spheres, and now we have this that will be also, since this is inverted, we already have the crack there. So since we know we want to animate this, I want to create a mask of the mask, basically. I will use the C in this case instead, and I will use a math node with a greater than. Let's see. So at 0.5, we are basically in the beginning there. I will go a little bit further. So from 0.7, and I will use a map range here. I want my 0.7 as one of the. So now I will use a value that goes from 0 to 1. And I want that 0 to 1 to be 0.7. And I want it to go to minus 0.6. Now if I plug this, I can go from, for example, at 0.5, we are there, and as we increase this number, we have this. And since I want my mask to do the opposite animation, because I want to crack from the bottom up, you can do it like this if you want. I will change this to less than instead, and also from 1 to 0. So now when I increase value, this white goes up, and at 0 we have nothing. So now I can use this to multiply my original crack here. And now this crack appears as we move this. So this will be animate crack. We will leave it at 1 for now because we want to see what we are doing. And let's see how this looks with the shading. Okay, so we can take all this here and Ctrl J and maybe call this shell. Now to continue, I want to create a few masks here. This will be Ctrl J, our crack alpha mask. I want my right and my left masks for the shell. So I can use the same X that we use here. And instead of compare with P, I will use greater than. Less than. So right and left. Now we want to be able to move the shells of the separate shells independently. So we are going to use the mask that we created. We can use vector math, and I will multiply my values by with the right shell mask, and also one with the left. Since we are using masks, they won't interfere with each other, so I can just add them to have them together. If I add value to one side, it won't be interfering with the other. And then I can add this to my timeline or line of transformation, or call it whatever you want. Now let's mark this. So now we move this to the right and this one to the left, and we see that we cannot see the other sphere that was the inside, because we need to multiply all our masks by the one that separated the two spheres. I will show you here at the beginning. My crack alpha mask here, if I go back again to this one, it's also masking the other sphere. So let's go back. We will use this. So now when we move or when we mask, we are not messing with our other sphere. Okay, let's connect this again. And this time we now can see the inside here. Now I want to have rotation on my shells. I want to rotate it a bit like this, so we can see a bit more the inside. This side that way. So a rotation in the z-axis. I will take this, vector rotate. If you remember from the exercises, we also subtract the same. So we end up with just the rotation. And now we have to also multiply by our left shell or right shell, depending on what we do first. I will use this one. You can always use, for example, here a Ctrl J, so you remember what this was. So at this point, if we rotate this angle, we have to take care of the center now. Let's move this. And now we can add this new transformation. Now if we rotate, we have rotation. The only thing is that it's rotating around this point. and I want it to rotate more or less in the center of this object. So what we can do is to link this center to the movement of this shell. To do this, I need to expose these values separately, so I will use a combine, and I will use this to move on X. And I will also use this value to move my center here. Okay, so even if we go, we won't go that far, but even if we do that, our center will adapt. And if we rotate, it will be like locally. And if we don't do that, it will be rotating around this point. So that's why we do this. So here we manage the rotation on Z. Let's call this right L rotation on Z. And now we will do the same. Control Shift W, Alt P. The center, it's fine. And I will use this instead for my vector. Have the same multiplication by the left shell mask. And now we want to rotate on the y-axis and add this. And as you can see, I forgot to subtract the same vector. And now we have this movement here. I want it to kind of rotate it a bit like this when we crack the egg and move it away. And now we will do the same, but for the left side. So we could even duplicate everything here. Alt P. And now we need this vector for the first. We need a mask for the right side now. This was wrong. It's the right side here. And now we need the left one. That's here. We use it to multiply here, and we can add. Let's move everything again. Now for this center, we will move it based on the movement we have here. Duplicate these two. We put it on the center here. And now we will take care of this one. Let's Ctrl J, left shell rotation on Z. Okay, so the part of the shells is done. We will now take care of the inside. Then we will do the shading and the animation.